Hello students, now let us see some examples on inclusion exclusion principle. So example, how many four-digit positive integers are there that begin or end with 3. Begin or end with 3. So now solution for this. Now first of all, let U be the set of 4-digit numbers. U be the set of 4-digit numbers. Let A is the set of such elements in U that begin with 3. And B is the set of elements from U such that it ends with 3. Obviously, now there are some numbers that satisfies both of them, that are begin with 3 and also end with 3. So now note that A intersection B is non-empty. That is the thing I want to say. Therefore, so what does this say? We have to use inclusion exclusion principle. Inclusion exclusion principle can be used. So therefore, let us find out the cardinality of A. What the A says, it begin with the 4 places we have to fill up. Fine, in A. Now these 4 places we have to fill up. Now in that one, that first place will be filled by what? 3 only. The number will be, first place is only 3. So it has only one choice. While the other have 10, each one have 10 choices. As it is 3, so the 0 is not included in that one, obviously. So only one choice it has. So how many? Total 10 to the power 3. So it will be 1000. Since this you can see. Fine. Now what about cardinality of B? What the B says? It ends with 3. So ends with 3, so only one choice is there. Fine. But now this 1000 place, 4-digit number, so 1000 place shouldn't consist what? 0. It won't be 0. So 3 will be 1. So now ends with 3, but it may begin with 3 also. Similar thing here, it may ends with 3. That's why 10 we have taken here. So here how many choices? 9 choices. Here 10 and here also 10 choices. But the last one have only one choice. Here similarly first one should have only one choice. That is 3. Fine. So it is 9 into 10 square. So it is how much? 900. It is 900. And cardinality of A intersection B. Cardinality of A intersection B. What is A intersection B? Now here, such a numbers which are begin with 3 and ends with 3. Means first and last place have only one choice. While the middle one have 2 choices. Sorry, not 2, that are 10 choices. Same choices. So these are how much? 10 square, that are what? 100. These are 100. Now the required required number is. What is the required number? We have to determine the 4-digit positive integer that are begin or ends with 3, both of them, or is there. So it is the cardinality of A union B according to our assumption for A and B. So cardinality of A union B. So let us use the inclusion exclusion principle. This is cardinality of A plus cardinality of B minus cardinality of A intersection B. So what is cardinality of A? It is 1000 plus cardinality of B is 9000 minus cardinality of A intersection B is what? 100. So it is 1800. This is our answer here. Now let us go for the next example. Now the next example says an investigator interviewed 100 students to determine their preferences for the 3 drinks. Which drinks? Milk, let us say M, coffee, say C, and tea, suppose, and tea, that is denoted by T, suppose. Now he reported that 10 students have all the 3 drinks. 10 students have all the 3 drinks. 20 students or 20 had milk and coffee. 30 had coffee and tea. 25 had milk and tea. 12 had milk only. 5 had coffee only, and 8 had tea only. Now the question is that first, how many did not take any of the 3 drinks? Any of the 3 drinks means the complement we have to determine. A union B union C, or the M union C union T complement, that one we have to determine. Fine. Second, how many take milk but not coffee. Third, how many take tea and coffee but not milk. These are the questions. So solution: What is the solution? Now let us draw the Venn diagram for this first. Now let it be, this part is denoted by M suppose. This is denoted by coffee and this will be denoted by tea suppose. Fine. Now what they say, 10 students have all the 3 drinks, means here we get 10 in all the 3, so it will be intersection of all 3. Now 20 had milk and coffee, so milk and coffee, this intersection part will have 20. Now 10 is already there, so here how many left? 10 are left. Now 30 had coffee and tea, so coffee and tea are how many? 30, so here how many are left? 20. Now 25 had milk and tea, so 25 are there, so milk and tea, 10 are already there, so how many are left? 15 are here. Now 12 had milk only, so here how many? 12. 5 had coffee only, so here 5, and 8 had tea only, so here what? 8 we get. Fine. Now this is what? The Venn diagram. Once the Venn diagram is formed, we can easily determine the answer. Now from the Venn diagram, first of all let us find out what is the union. What is the, how many students are, this is the report for how many students, that thing we will find out first. Fine. So now here M union C union what? T first. This is nothing but the addition of all these digits here. So let me take 12 plus 5 plus 8 plus 10 plus 10 plus 20 plus 50. Okay, so that is how much? It is nothing but 80. Now what first they say, how many didn't take any of the 3 drinks? So this drink will be taken by how many students? 80 students. Total number of students are how many? 100. So none of the, not now first number of students do not take any drink are how many? These are cardinality, complement, as I say earlier to you, this is complement of this, and this is nothing but total number of students minus the union, M union C union what? T. Total number are how many? 100 minus this is 80, so that is equal to how much? 20 is our answer here. Now the answer of second, how many take milk but not coffee? Milk but not coffee, so it is nothing but this is a set of milk and this is a set of coffee. Fine. So here this is nothing but what? Now this is a complement, this is what? A complement or the subtraction, difference between M and what? C. So if we take M minus C, from M and C is this, so M minus C we will take, then this part is left, this much part is left. So now that part consists this 12 and 15 only, this part is left. Look at this part is left there, this much part. This is what? M minus C, difference set. So 12 plus 15, so it will be 27. So the answer of second will be 27. So number of students taking milk but not what? Coffee. But not coffee. That is cardinality of M minus C. M minus C from Venn diagram we can easily observe. So it will consist only these 12 and 15. So the answer will be what? 27. Now the answer of third, how many take tea, coffee but not milk? So number of students take tea and coffee but not milk. Tea and coffee but not milk are how many? Now this is tea and coffee means what? T intersection C minus not milk means what? We will subtract which part? This is common for all. This part we will subtract from this. Now T intersection C. T intersection C minus this is nothing but what is T intersection C? T intersection C will have this part. How much? 20 plus 10. So that is how much? 30. Minus intersection of all will have this 10. So what is the answer? The answer will be what? 20 here. This is the solution for this question. Now let's go for the next question. Now simply the length of the question is bigger but the answers are very small here. Now just you have to improve your logic and solve these questions. So now example, next, a school has 200 students. School has 200 students with 80 students taking each of the three subjects. Each of the three subjects. Each of the three subjects. That are which one? Trigonometry, probability, and basket weaving. 80 students have taken each of these subjects. There are 30 students taking any given pair of these subjects, means intersections in between two subjects is what? 30. Any pair is given. So pairwise if we take, then it will be 30. Fine. And 15 students taking all three subjects. Okay, means intersection in all. Now how many students are taking none of these? How many students are taking none of these three subjects? None of these three subjects means what? Again the same type of question, that complements of the A union B union C. Let me assume the first subject is A, set B and set C as such. Then next one more question is here. How many students are taking only probability? This is a question. Now if we solve this one using Venn diagram, then it is very easy again. So let me take solution. Now let us denote. Now let me write first trigonometry. Trigonometry is suppose denoted by what? Is suppose T, and next probability is suppose what? P, and basket weaving basket weaving is suppose B. This is suppose, these are our assumptions. Let this be. Fine. Now one more thing is given to us. The total number of students in that school are how many? 200. So let me say U will be what? 200. Universal set. Now let us draw the Venn diagram for this. Now what this says, 80 students take each of the subject, 30 students take pairwise. Now let it be T, this is P, and this is suppose B. Okay. Now 15 students taking all the three. So here how much we get? 50. Now here the intersection is 30, here also intersection 30, here also intersection 30. 15 is there. So for each one 15 are left. Fine. Now and for each one there are 80 students. So this is how much? 15 means 45 are gone. Here also 45 gone. Here also 45 gone. Look at here in B. These are already 45. So 80 minus 45. So it will be what? 35. So here we get 35. Here also we get 35. And here also we get how much? 35. This is our solution here. Now what we have to determine? That how many students taking none of these? None of these means what? In complement of union. Fine. So let's find out first. First we have, for first one we have to find A union B union C complement. This one. So therefore first of all find out not A union. Now we have given name here as T, P and B. Sorry for that. So T union P union B complement. Fine. So now first of all find out T union P union B using inclusion exclusion principle. So it will be cardinality of T plus cardinality of P plus cardinality of B minus cardinality of T intersection P minus cardinality of P intersection B minus cardinality of T intersection B plus T intersection P intersection what? B. This is our solution here. So what does this? This is 80 plus 80 plus 80 minus 30 minus 30 minus 30 plus how much? 15. So the answer is 165. Therefore, the students taking neither of the subjects equal to what? This T union P union B complement, or that is same as T complement of T intersection complement of P intersection complement of B using De Morgan's law, or that is same as universal set minus this T union P union B also. So universal set have how many elements? 200 elements, and this is 165. So the answer is 35. Now the next part, second part is what? The number of students who take probability only. So number of students taking only probability. That are what? Now only probability. So only this much part. So we won't take this part. So okay, here only probability means how much? From the Venn diagram we can easily find out it. Only probability will be this. This is an intersection. So only probability is how much? Only 35 is this. This is our answer here. Now let us take one more question and then we will stop for this inclusion exclusion principle. Okay. Now next question, example. The student in a hostel were asked whether they had a TV set, or a computer, okay, in their rooms. The result showed that 650 students had a TV set, 150 didn't have a TV set. 175 had a computer. And 50 had neither a TV set nor a computer. Therefore, find the number of students who first live in a hostel. Second, have both TV set and a computer. Both a TV set and a computer. And third, have only a computer. So solution: let A be the set of students who have TV set. B be the set of students who have computer. Okay. Now, given that, what is given to us? Cardinality of A is how much? 650. Because the 650 students have TV set, 150 don't have a TV set. Means what? The complement of A will be what? 150. Then this cardinality of B is how much? 175. And A bar intersection B bar, none of them, neither A nor B, are how much? 50. Now first, number of students who live in a hostel are how much? This cardinality of A plus cardinality of A complement. So that is what? 650 plus 150. So that is equal to 800. This is the answer here. Now the next thing, second one, have both TV and a computer. So number of students who have both a TV set and a computer. Both have both TV set and a computer. This is what A intersection B. Now to determine A intersection B, first of all we should have A union B. We have A and B with us. So here we have this cardinality of A complement intersection B complement, that is how much? 50. Fine. Now using this one also we can determine A union B. Therefore cardinality of A union B is what? Total minus what? A complement intersection B complement. So total is how much? This 800 minus this 50. So this is how much? 750. A union B is 750. Fine. Therefore now A intersection B equal to what? Cardinality of A plus cardinality of B minus cardinality of A union B, using inclusion exclusion principle. Using inclusion exclusion what? Principle. This is the case. So here this is what? 650 plus 175 minus 750. So this is how much the answer? This answer will be what? 75. And the third, number of students who have only computer, or how, this is what? Don't have a TV but they have a computer. This is the answer here. So that is what? B minus their intersection. So that is 175 minus 75. So it will be what? 100. This is the answer here. So here we will stop for this. Now this is the conclusion of what? Inclusion exclusion principle. Now in next video we will see pigeonhole principle and the examples on them. Thank you.